So I'm gonna walk you through my thought process of how I predict problems based on these things that are given to us, the reactant and the reagents. And
Okay.
as I walk them through, I'm gonna have you write the mechanism as well, like the arrows, on how we get the final product. So what kind of substrate do we have in the reactant here? Let's look at this carbon holding the leaving group. What type of substrate is that carbon? Is it primary, secondary, or tertiary?
Isn't it secondary?
Yep, it's
Can
secondary because it's bonded to two other carbons.
you also identify secondary just by the what's it called? The wedge.
Uh, the
I feel like
wedge.
all the secondaries I've seen, like I've just always had a wedge.
Oh no. It doesn't have to have a wedge. Like it could be a dash. It doesn't have to be a
Okay.
wedge. Yeah. So well, can you see this like laser thing?
Yeah.
Oh, okay. This is like a new tool I haven't seen before. I was like, what the heck? Uh, okay. So whenever you see Na or K, what charge does that have?
In Na.
Yeah, like Na ion here. What charge does Na or K usually have? Positive, negative?
Oh, Na has positive.
Yeah, positive
Yeah.
charge. So whatever is attached to the Na would have to be negatively charged. So the
Okay.
negative charge here is this N3 ion there.
Got it.
And if this N3 is a negative charge ion, would that make it a nucleophile or an electrophile?
It would be an electrophile.
So electrophiles, the definition is that it is partially positive or fully positive. Definition of a nucleophile, if it is that a molecule that is partially negative or fully negative. So since this N3 is fully negative, this N3 is going to be a nucleophile,
Okay.
right? Do you know what charge this carbon is over here, holding the leaving group bromine?
Like,
So
are you asking if it's like a positive or negative charge?
yeah, positive and negative. We know that it's bonded to an electronegative atom bromine, where bromine is withdrawing electrons from that carbon right there.
So it'd be
And
negative.
yeah, the bromine would be partially negative because it's gaining electrons, whereas the carbon here is losing electrons, making it more positive.
Okay.
Right. So this carbon here that's partially positive is going to be the electrophile. And in organic chemistry, nucleophiles always attack electrophiles.
Sounds good.
Uh-huh. So this negative charge here is going to go all around here and attack that carbon right there. So when we draw arrows, the arrows always start from something that's negative and it goes to something that's positive. So this negative charge N3 is attacking this carbon holding the Br there.
Sounds good.
And right after that, we have to kick out the bromine because the carbon will have 5 bonds, which is way too much bonds. That would break the octet rule. We have to kick something out, which is this good living good bromine right there.
Sounds good. Okay.
And then the transition state would look something like this, where we know it's a backside attack. These dotted lines show that the bromine bond to the carbon is being broken, and these dotted lines on top show that the bond between carbon and N3 is being formed. So this is happening at the same time. This bond is being formed, and the other bond is being broken at the same time. And you
Yeah.
notice
Okay.
how the nucleophile and leaving group are 180 degrees apart from each other? Like this N3 here and this Br are 180 degrees like anti
Yeah.
from each other. This is important because this is what backside attack is. It attacks on the backside of the leaving group. So when she tells you to draw the mechanism of the SN2 with the transition state, which is this symbol over here, you would have to include that these are 180 degrees apart from each other. And then when that happens, we get our final product where the stereochemistry inverts. So since the bromine was a wedge, what is the opposite of a wedge?
And a dash.
Dash, right? So this carbon now would have a dashed bond to N3.
So you said it switches from dash to wedge. Is it you said from because positive to negative or something else?
It switches from a wedge to a dash because of this backside attack here. You know how this
Okay.
N3 minus is coming on the back door or like backside behind the BR there?
Yeah.
As it's coming behind, that's think of it as like the opposite of whatever this bond is. This bond is wedge, so the opposite of that is a dash.
Perfect.
Mhm.